Hi guys, so welcome to another video. The topic for today is exponents and roots. Okay, some people also call it surds and indices. They are all the same. It's a very easy topic. Okay, so without further ado, let's directly get into it. Alright, so exponents, okay, are a to the power b. Right, what does this mean? It means a is multiplied to itself b times. Okay, a is multiplied to itself b times. Okay, this right is called your base, this is your power. Okay, this is called, a is called base, b is called power. This is one topic that you should again definitely target in exam. Okay, the reason I am saying that is there are few properties. Okay, all the questions are based on those properties. So if you understand those properties, if you understand how to apply them, you can solve all the questions from this topic. Okay, so again, let's just dive right into it. So since we know that a to the power b, right, we know a to the power b is a multiplied by itself b times, right? For example, 2 to the power 5 is 2 multiplied by itself 5 times, so that's 32, right? So based on this, we have certain properties that we should know. First, a to the power x times a to the power y is a to the power x plus y. Okay, if you think about it, see, what is a to the power x? Okay, a multiplied by itself x times. Okay, what is a to the power y? Again, a multiplied by itself y times. So if you count all of it, a has been multiplied to itself x plus y times, right? If you think about it, a has been multiplied to itself x and then y, so x plus y times. Hence, a power x times a power y is a power x plus y. Likewise, a power x divided by a power y is a to the power x minus y. Okay, which is the exact same explanation. Okay, then we have a power x whole to the power y. This is a power x into y. Okay, if you want, this also follows the same concept. See, a power x whole power y will mean a power x is multiplied to itself y times. So x is getting added to itself y times, right? So you have a x plus x plus x y times. Okay, that is a power x into y. Okay, a power x whole power y thus becomes a power xy. Into the next one, we have negative power. A to the power minus 1 is 1 by a. Okay, negative power simply means reciprocal. Alright, so if you just think more, or if we try more on this, a to the power minus x is 1 over a to the power x, or using the previous one, 1 by a whole to the power x. Okay, this is just multiplication. 1 to the power x is 1 only, right? Or say a by b to the power minus x is b by a whole to the power x. Alright, the same property just written in 3 different forms. Moving on to the next one, anything to the power 0 is 1. Okay, anything to the power 0 is 1. Alright, so these are all the properties when your base is constant. Okay, if you see in all the questions or all the properties, the base remains fixed a. Alright, what happens if I change the base and keep the power the same? Okay, so say we have a to the power x multiplied by b to the power x. Then you can multiply the two bases together and have a common power x. Okay, again, how does this work? So see, you have a to the power x means a is multiplied by itself x times. B to the power x means b is multiplied by itself x times. If I combine the two and multiply each a and b together, So that's AB into AB. I am pairing them, okay? I am pairing each A and B together. That will also go on for x times. So that will become AB to the power x. Alright. Then the same, whatever happens in multiplication, the same thing happens for division. So A to the power x divided by B to the power x is A by B whole to the power x. Okay. So here what happened, what have we learned till now? What if the base is constant, right? And what if the powers are constant? Okay. Now say everything is different. Okay. Say now we are looking at everything being different. Okay. Your base is also different, power is also different. Say for example, A power x is given to me as B power y. Alright. A to the power x is equal to B to the power y. Okay. Then what we can do? We can write A as B to the power y by x. Okay. A as B to the power y by x. So this x from the numerator or the power goes in cross multiplication, okay, to the other side. So A can be written as B to the power y by x. Similarly, B can be written as A to the power x by y. Alright, why just find A? What if I want to find B? So B can simply be written as A to the power x by y. Right? This is again one very important property. Okay, when is this useful? When everything is different. Okay, when your bases are different, powers are different, right? Then we can use this property. Alright. So now if you understand that, okay, right, I understand the properties, what do I do? So let's look into how you're supposed to solve the questions. Alright. So whenever we are solving questions, there are two things that we try to look for. Okay, one is either we make the bases equal on both sides of the equation, or we make the powers equal. Okay. Now those who are thinking about grammar, right, we can do one more thing, right? I'm sorry, if I'm deviating, it's just my brain is working like that. See, we make either the bases or the powers equal. Okay, a more efficient way to write the same. Okay, a more efficient way to write the same. Okay, any which ways, forget this. Let's focus on the concept, right? So the concept is, let's see, you can either try and make the bases equal, or you can try and make the powers equal and then solve. All right, but before you do, remember one thing. Okay, before you do, remember one thing. Say if a power x is equal to a power y. Okay, say we solve some question and we end up with a power x equal to a power y. Okay, no problem, great. Okay, don't become super happy and say, oh, a and a cancel or x and y are equal. Okay, don't do that. Okay, hold your horses. Remember, if a power x is a power y, then point number one. Okay, if a is 0 or 1. Okay, if a is 0 or 1, see, 1 power anything is 1. All right, if a is 0 or 1, then x and y can be anything. Okay, they need not be equal. Okay, so don't just jump, don't become super happy and say, oh, a and a are equal, so x is equal to y. No, right? Remember, if a is 0 or 1, okay, if a is 0 or 1, see, 0 power anything is 0, 1 power anything is 1. So x and y can be anything. All right. Similarly, right, if a is minus 1, okay, if a is minus 1, right, then x and y are both odd or even. Okay, then x and y are either both odd or both even. Alright, because minus 1 to the power odd, okay, minus 1 to the power odd is minus 1 only, minus 1 to the power even is plus 1. So x and y need not be equal. Similarly, only if a is not equal to minus 1, 0 and 1, okay, only if you are able to establish that a is not equal to minus 1, 0 or 1, then you say x is equal to y. Okay, only then can you say that x is equal to y. Now if you understand this, let's look at a different scenario, because I said, right, that you can either make the bases equal on both sides to solve, or you can make powers equal, right? So say if you have a power x is equal to b power x, alright, a power x is equal to b power x. So again, do not jump and say, oh, a and b are equal. No, right? No. Similarly, see, case number 1, if x is 0, okay, if x is 0, right, then anything power 0 is 1. We just studied that. So a and b can be anything. Okay, a and b can be anything. Alright. Similarly, if x is even other than 0, okay, if x is an even number other than 0, think about it, what will happen? If a square is equal to b square, then what happens? Right? Do not say a and b are equal, okay? We have done this in absolute values, alright? Square root of variables is modulus. So then you will say modulus of a is equal to modulus of b. Remember, square root of variables is always modulus, alright? So if a square is equal to b square, okay, don't jump the gun and say, oh, a and b are equal. Remember, square root is modulus. So modulus a is equal to modulus b. Alright, and finally, if x is odd, okay, if x is odd, then you can say, right, that a and b are equal. Okay, so only if x is odd or a fraction and all, then you can say a and b are equal. Okay, so I hope you understand this as well. So if you understand this, let's solve some questions based only on this this much. Then we'll learn the concept of roots. Alright, so if we see, we have 3 power k is equal to 2, and the question is 3 power 4k plus 3. Right? So if I just write it down, we have 3 power k is equal to 2. So see, the basis powers, everything is different. Alright, what do we need to know? We need to know 3 power 4k plus 3. Alright, so let's break this down first. As I told you that everything is property based. So this can be written as 3 power 4k into 3 power 3. Alright, see, this is reverse of the property. We have a power x into a power y as a power x plus y. So a power x plus y will become a power x into a power y. Alright, this can further be written as 3 power k whole to the power 4, okay, times 3 power 3. Okay, again, reverse of the property, a power x power y is a power xy. So a power xy is a power x whole power y. 3 power 4k is 3 power k whole power 4. Alright. 3 power k we know is 2. So that's 2 power 4 times 3 power 3. That is 16 times 27, 480 minus 48, 432. Okay. If you want to solve this quickly, see, I know the table of 16. So 16, okay. Let's use it. So 16 times 30, 16 3s are 48, so 480, 16 times 3 is 48. So 480 minus 48, 432. Moving on to the next one, we have 9 power n plus 1 plus 9 to the power n is equal to 30. Alright, 9 power n plus 1 plus 9 power n is 30. Same thing that we did in the previous question. 9 power n times 9 power 1 plus 9 power n is 30. I can take 9 power n common. That's 9 power 1 plus 1 is 30. 9 power n times 10 is 30. 9 power n is 3. Make the bases same. So 3 power 2n is 3 power 1. Since the base is not minus 1, 0 or 1, I can write 2n as 1 or n as half. Alright, and that is what we want. We want n. N is half. Okay. Alright, continuing on the same, we have d is 256. D to the power d is 2 to the power q. Okay, so we know d is 256. D to the power d is 2 to the power q. Alright, so and I want q. Again, what you can do, either make the bases same or the power same. If I just substitute the value, this is 256 power 256, right, is 2 to the power q. What can we do? Because we want q, we have to make the bases same, right? So 256 can be written as 2 to the power 8, right? 256 can be written as 2 to the power 8. Don't change this 256 again as 2 to the power 8. Okay, you will just lengthen your process. Okay, let it be 256 itself. So this becomes a power b times a power c is a power bc. So that is 256 2 power q. Bases are same. Q is 2048. Okay, q is 2048. All right. Now, if you see, I told you don't convert this 256 again into 2 power 8. You can do that, you will get to the same answer, but you are just complicating your steps. See, if I write it as 2 power 8 whole power 2 power 8 as 2 power q, there is no problem, there is nothing wrong in that. Again, the power multiplies, so that's 2 power 8 times 2 power 8. Okay, it doesn't become 8 power 8 into 2, 16 and then 16 power 8. It also does not become 2 into 8, 16 and then 16 into 8, okay, because this is 2 power 8, not the whole thing power 8. Okay, so this is 2 power q. Alright, now 8 can be written as 2 power 3 to 2 power 8 is 2 power q. 2 power 11, 2 power 11 is 2 power q. 2 power 11 is q, which is again 2048. Right? But again, you're just making your process a little bit more complicated. Let it be like this. Alright, so moving to the next one, we need sum of all the digits. Number is 10 power 50 minus 57. Again, it's a very big number. Okay, let's just write it down in a very simple manner. Okay. We have 10 power 50. So see, 10 power 1 means 1 followed by 1 0. Right? 10 power 50 means 1 is followed by 50 zeros. So these are 50 digits. Okay, so these are 50 zeros and a 1, so total 51 digits, and we need to subtract 57 from this. Okay, let's just do that. 0 minus 7 can't be done, so I start taking carryovers, right? This becomes 10, the 10 becomes 9, right? Goes on 9, 9, 9, continues. This is 9, this is 10, right? So what does that tell you? See, the 1 is gone. So there were 51 digits, 1 is gone. So now 50 digits are left. Okay, of those 50 digits, 49 are 9, right? These 49 are 9, and the last digit is 10. 10 minus 7, we get 3. 9 minus 5, 4. So that's 2 digits. How many are left? 48 digits are left, and they will all be 9. Okay, so these are 48 digits. Okay, now what do we want? We want the sum of the digits, right? So sum of the digits will be 9 plus 9 plus 9, 48 times, plus 4 plus 3, right? So that is 9 times 48 plus 4 plus 3, that is 432 plus 7, 439. Moving on from our exponents to the portion where we focus on roots. Okay, so till now what we discussed was simple exponents, right? You had a power b, everything was good. Now we have roots. Roots are not different from exponents. Okay, they are the same. They are just fractional powers. See, if you think about it, what have we covered? A power some integer, a positive integer or a negative integer or a zero, right? Up 0 is also an integer, not positive, negative, but right. Similarly, what if the power is fraction? Okay, then what do we do? So the fractional powers are roots. Okay, a mth root of a is nothing but a power 1 by m. Okay, mth root of a is simply a power 1 by m. So now, for example, say square root of 5 is 5 power 1 by 2. Cube root of 5 is 5 power 1 by 3. Fourth root of 5 is simply 5 power 1 by 4, and so on. Okay, so now if you understand how to convert a root to an exponent, then all the properties of exponents can be applied here, right? Say for example, mth root of a into mth root of b. The bases are different but the power is same, right? This is a power 1 by m into b power 1 by m, which is simply ab power 1 by m, right? Which is mth root of ab. Okay, a power 1 by m, right? A power mth root of a power 1 by m, mth root of b is simply mth root of ab. All right. Similarly, division, mth root of a divided by mth root of b is simply mth root of a by b. Okay, mth root of a divided by mth root of b is simply mth root of a by b. Okay, so this, as I said, all the same powers, all the same properties follow, right? Say power of power, right? Say mth root of a power n, okay, can be written as mth root of a whole power n, right? Both are simply, right, simply a power 1 by m into n, which is a power n into 1 by m, right? So both are essentially the same. So these are, right, if you understand roots and you know how to convert them into exponents, then these are the three properties of roots that we need to know. Okay, and again questions can be solved by using these properties. All right? So if you understand this, then let's move to the next concept, that is the concept of rationalization. Okay, the concept of rationalization is that we do not want root in the denominator. Okay, Okay, so we solve the question, we get an answer, great, right? But a convention says that we don't prefer that root, cube root, square root, any root, sort of root be in the denominator. Okay, say for example, I solve some question and the answer comes as 6 over root 2. So we don't like that. So what do? We rationalize the denominator. Okay, how do we rationalize it? We multiply the numerator and denominator by root 2. See, the goal of rationalization, okay, the goal of rationalization is to remove, okay, root from the denominator. Okay, so any operation that will not change my answer, but help me remove the root from the denominator works. So since there was a single root here, what did we do? We just multiplied by the same term. Okay, so what happens because of this? Numerator becomes 6 root 2, root 2 times root 2 is 2, denominator becomes 2, you can cancel it, answer becomes 3 root 2. Okay, you cancel it, answer becomes 3 root 2. Alright, similarly, say we have 6 over root 3 plus 1. Okay, say we have 6 over root 3 plus 1. Now I can't multiply by root 3 because the root 3 into 1 will stay. So the purpose won't get solved. I can't multiply by root 3 plus 1 also, because then this will become root 3 plus 1 whole square. A plus b whole square is a square plus b square plus 2ab. So in your 2ab, this will again remain. Alright. So then what do? We multiply by the opposite sign. Okay, we multiply by the opposite sign. Okay, why do we do that? So that this becomes a plus b, this is a minus b, and we end up with a square minus b square. The moment you do a square, the root from 3 will go away. Right? The moment we do a square, the root from 3 goes away. So we get 6 root 3 minus 1 over root 3 square minus 1 square. If you solve it, that's 6 root 3 minus 1 by 3 minus 1. Alright, if you solve it, again 6 and 2 cancels out, answer becomes 3 root 3 minus 1. Okay, 3 into root 3 minus 1. Alright. Okay, so if you understand the concept of rationalization, I'm just giving you one homework. Try it and think, how can you rationalize this? Say the question is 6 over cube root of 3 minus 1. Okay, say we have, okay, 6 over cube root of 3 minus 1. Try to rationalize this and see. Okay, alright, if you understand that, then let's solve some questions. Okay, so we know P is 1 over root 20 minus root 19, Q is 1 over root 20 plus root 19, and they are asking us P square plus 2PQ plus Q square. Okay, so we have P as 1 over root 20 minus root 19, Q as 1 over root 20 plus root 19, and we need to know P square plus 2PQ plus Q square. You see denominators, rationalize it. So this gets multiplied by root 20 plus root 19. Right? We'll solve Q later. This is simply root 20 plus root 19. Denominator becomes 1 because root 20 square is 20 minus 19. 20 minus 19 is 1. Similarly, if I rationalize this, I multiply by root 20 minus root 19. Solve it. Q becomes root 20 minus root 19. Now that you have P and Q, again don't just jump and directly substitute the values. Okay, see what is it that they want. They want P square plus 2PQ plus Q square. Does it look familiar? Does it look familiar to any formula? If you see, this is P plus Q the whole square, right? This is P plus Q the whole square. So what do I do? Now I substitute. So I have root 20 plus root 19 plus root 20 minus root 19 the whole square. Root 19 cancels out. 2 root 20 the whole square, right? 2 root 20 the whole square. So that is 4 times 20, 80. Okay, 4 times 20, 80. Interesting question here. We need to find the value of this. Now if you look at it, you might think, oh, how will we do this, so much to solve? But remember, the only thing we know when root is there in the denominator is to rationalize. So let's look at it. So we have 1 over root 1 plus root 2 plus 1 over root 2 plus root 3, 1 over root 3 plus root 4 till 1 over root 80 plus root 81. Right? See, the only thing we know is to rationalize. So let's do that. Okay. So for the first one, you will multiply by root 2 minus root 1. Right? 1 plus root 2. For second one, root 3 minus root 2 into 1 by root 3 plus root 2 and so on. Right? The last one will be 1 over root 80 plus root 81 times root 81 minus root 80, root 81 minus root 80. Okay. Now root 2 minus root 1. Okay. Root 2 minus root 1, which if you see is 1 only, over 2 minus 1, which is 1, plus root 3 minus root 2 over 1 plus root 4 minus root 3. If you see the pattern, right, root 80 minus root 79 by 1 plus root 81 minus root 80 by 1. Okay, common LCM 1 or 1 is not even in the denominator. So if you just see, so root 2 minus root 1 plus root 3 minus root 2 plus root 4 minus root 3 goes on till root 80 minus root 79, 81 minus root 80. If you see, root 2 cancels out, root 3 cancels out, root 4 will cancel out. Similarly, root 80 cancels out, 79 cancels out. The only two terms remaining are root 81 minus root 1. Root 81 we know is 9, root 1 is 1, answer becomes 8. Okay, so it doesn't matter how difficult or complex the question looks. Remember, you know your concept, you have to apply it and then see where it goes. So moving on to the last concept for today, this is square root of a surd. Okay, so see, what we have learned till now is exponents. We have understood the powers and all, right? Then we have learned roots or surds. Okay, now what we are looking at is square root of a surd. Okay, what does this mean? Say for example, see, if I tell you what is square root of 9, you'll say 3. Okay, don't say plus minus 3, say 3. Okay, similarly, if I say square root of x square, yes, say modulus x. Very good, right? Say modulus x, because square root of variables is modulus, right? However, if I ask what is square root of 7 plus 4 root 3, okay, 7 plus 4 root 3, then what happens? Now this is little complex. We can't do, okay, don't do like, okay, root 3 is 1.7, then into 4, then plus 7, and that becomes like complex, right? There has to be a simpler way, right? And there is. Okay, so see, these are two terms, right? These are two terms. So I'll say let the square root of this, because this is a surd, right? Because this is a surd, the square root also has to be a surd. So that be two terms again. Okay, because we have two terms here, let the square root be also two terms. Because there is a plus sign here, the square root will also have plus sign, right? And since this is a surd, this will be root a plus root b. Okay, so what did we do? We said The way we solve any math question, whatever is unknown, let that be x. Similarly, let square root of this be root a plus root b. Why two terms? Because we have two terms here. Why plus sign? Because we have plus sign. Had there been a minus sign, we would have also mirrored the minus sign. Okay. Had there been a minus sign, we would have also mirrored a minus sign. Okay. Alright, let's solve it here. So we have 7 plus 4 root 3 is equal to root a plus root b. Okay, now that if you want to remove the square root, what do you do? Square both sides. Okay, you simply square both sides. So we get root of 7 plus 4 root 3 the whole square is equal to root a plus root b the whole square. Right, square and root goes out. 7 plus 4 root 3 root a plus root b whole square is a square root a square plus root b square plus 2 root a root b. Right, that is 7 plus 4 root 3 is equal to a plus b plus 2 root ab. Okay, now what do we do? Just equate the like terms. See, this is an integer. Here, this has to be an integer. So, a plus b is equal to 7. Similarly, this is a surd or a root. This is also a surd or root. So, they need to be equal. So, 2 root ab is equal to 4 root 3. Let me square. I don't want root on both sides. Right? I can cancel this 2 and 2 first. Let me square. So, I get ab is equal to 12. Okay. I get ab is equal to 12. Right? Now, if I look at it, a plus b is 7. AB is 12. Can you think of two numbers whose product is 12 and sum is 7? Right? They are 4 and 3. They are 4 and 3. That means A is equal to 4, B is equal to 3. Okay. So your answer becomes root 4 plus root 3. Okay. The answer becomes root 4 plus root 3, which is 2 plus root 3, which is 2 plus root 3. So this is how we find square root of surds. So now we have x as 5 minus 2 root 6 and we are supposed to find root x minus 1 over root x. Right? We have to find root x over 1 minus 1 over root x. Okay. So this is same as what we did just now. See, x is 5 minus 2 root 6. So let's find square root of x first. So we do square root on both sides. Okay, we need to find square root of 5 minus 2 root 6. For that, as I said, two terms. So two terms, minus sign, square root, square root. Okay, so let square root of x be root a minus root b. Right, square root of 5 minus 2 root 6. Now if you square both sides, right, if you square both sides, 5 minus 2 root 6 is a plus b minus 2 root ab. Okay, a plus b minus 2 root ab. Again, like terms. So a plus b is 5 minus 2 root ab is minus 2 root 6. Minus minus cancels. 2 cancels. Square both sides. ab is 6. Again, think of numbers. A plus b is 5, ab is 6. The numbers are 3 and 2. So a is 3, b is 2. Okay, what does that tell you? Okay, what does that tell you? That square root of x, okay, is root 3 minus root 2. Okay, it is root 3 minus root. Don't do root 2 minus root 3 because it can't be negative. Right? Square root of numbers is always positive. So it has to be greater minus smaller number. Alright. Again, don't jump. Question is not over yet. Substitute the values. Okay, what do we have? Root 3 minus root 2 minus 1 over root 3 minus root 2. Again, we don't want root in the denominator. Rationalize. Root 3 minus root 2 minus root 3 minus root 2 into root 3 plus root 2. Okay, root 3 minus root 2, a plus b, a minus b, denominator becomes 1, root 3 plus root 2, root 3 minus root 2 minus root 3 minus root 2. Answer is minus 2 root 2. Okay, answer is minus 2 root 2. Moving on to the next one. So we have x to the power 5 plus x to the power minus 5 is 11. They are asking x to the power 10 plus x to the power minus 10. Obviously, don't try to plug in values and all. No need of that. Just see, this is power 5, power 10. Okay. X power 5 plus 1 over x power 5 is equal to 11. They are asking x power 10 plus 1 over x power 10. Now think, how can I go from power 5 to power 10? We can square both sides, right? Because this is square of that. So let's just square both sides. We get x power 10 plus 1 by x power 10 plus 2 b is equal to 11 square, which is 121. We get x power 10 plus 1 by x power 10 plus 2 is 121. The answer is 119. Right? The answer is 119. Right? Again, another interesting question. We have 3 power x is equal to 4 power y is equal to 12 power minus z. Okay, and we have to find 1 over x plus 1 over y plus 1 over z. Right? So we have 3 power x is equal to 4 power y is equal to 12 power minus z. Okay, bases are different, powers are different. Okay, everything is different. No problem. Either we make the bases same or we make the power same. Since the powers are 3 different variables, there is no way for you to make powers same, right? So why even try for that? Now think, how can I make bases same? Okay, now think, how can I make the bases same? So looking at 3, 4 and 12, what comes to my mind is 3 times 4 is 12. Okay, what comes to my mind is 3 times 4 is 12. Okay, so let's do one thing. Let me find 3 here, right? So that 12 becomes 12. So see, we are doing 3 power x is 12 power minus z. 3 is equal to 12 power minus z by x, right? The power goes, right, to the other side in power. Similarly, 4 power y is 12 power minus z. 4 is equal to 12 power minus z by 4. Sorry, my bad. Z by y. Okay. Now I have singled out my 3, singled out my 4. Let's substitute these values there so that my bases become same. Right? See, 12 power minus z over x times 12 power minus z over y is equal to 12 power 1. Bases are same. So minus z over x plus minus z over y is 1. You can take z common, send it minus z common. 1 over x plus 1 over y is 1. Z can go to the other side. 1 by x plus 1 by y is minus 1 by z. Comes here, 1 by x plus 1 by y plus 1 by z is equal to 0. Okay. Again, remember, doesn't matter what they give. The only thing you can do to solve the question is either make the bases equal or the powers equal. Okay. Alright, moving to the next one. So we have M and N are 4-digit positive integers, A, B, C, D and P, Q, R, S. Okay, so M is a 4-digit positive integer A, B, C, D and N is a 4-digit positive integer P, Q, R, S. Okay, for numbers M and N, function B is this. Alright, now function B is defined as 5237. Okay, 5 power A, 2 power B, 3 power C, 7 power D divided by 5 power P, Q, R, S. Okay, so V is defined as this. You have another function Y defined as M minus N by 10. Okay, Y is defined as M minus N by 10. Okay, now V is 81. So we know V is 81. We have to find the value of Y. We have to find the value of Y. No problem. Again, it's just properties. So because 81 is given to me, I need to start from here. 5 power A by 5 power B becomes A minus P. 2 power B minus Q. 3 power C minus R. 7 power D minus S. Okay, when I divide, the power subtract. This is equal to 81. 81 is 3 power 4. Okay, 81 is 3 power 4. So if I solve that, I basically get 5 power A minus B, 2 power B minus Q, 3 power C minus R, 7 power D minus S is equal to 3 power 4. Now what can we do? We can only equate bases, right? Either equate the bases or powers, right? Now this 3 power 4, I will write it as, okay, this 3 power 4, I will write it as 5 power 0, 2 power 0, 3 power 4 and 7 power 0, because there is no 5 there, so 5 power 0. Now if I equate, so I get A minus P is 0, that means A is P. Similarly, B is Q. Similarly, C minus R is 4 and D is equal to S. Okay, I get A and P are equal, B and Q are equal, C minus R is 4 and D is equal to S. Alright, so this is done. Now what do they want? Y. Y is M minus N. Okay, so let me do M minus N. M is a 4-digit number A, B, C, D minus N, 4-digit number P, Q, R, S. I'd simply do the subtraction. So D minus S, I know D and S are equal. So D minus S, 0. C minus R I know is 4. B minus Q, again 0. A minus P, again 0. So M minus N is simply 40. Okay, so if M minus N is 40, Y is 40 by 10, which is 4. Y is 40 by 10, which is 4. Okay, so even if it is a complex word problem, need not worry, right? Just solve it step by step. Okay. Hi guys, so I hope you like the way we covered this topic. Remember, this was a concept builder video wherein we covered a simple concept and tried to solve all the questions using that concept. There is an advanced video with more tricks, right, that will come as part of this series. If you have any doubts, you can post them in the comment section and we can make a solution video for that. Also, you can practice free material of the same topic from our website, okay, and take those tests.